is nothing but 1.39 into 10 raised to 6 divided by the 1.2, that is the weight, 1.2 into 10 raised to 6. Okay, so this 10 raised to 6 and 10 raised to 6 will be cancelled out, and this line you can see approximately. In this calculation will you can get the approximately the value is coming out to be approximately 1.6. Okay, why we are going to calculate this ratio? Because this ratio is what? This ratio is nothing but 1.6 divided by 1. Okay? So this ratio is nothing but 1.6 divided by 1. So if you consider the weight, this is nothing but the weight. If you consider weight is equal to 1 centimeter, then you should consider the aerodynamic lift equal to 1.6 centimeter. Right? If I consider the weight is equal to 2 centimeter, then I should consider the aerodynamic lift nothing but equal to 3.2 centimeter. So double we will do. Okay. So this ratio is very important. This ratio will tell you what should be the line of that vector force when you draw the vector diagram. Okay. So here if I consider 5 centimeter, you have to multiply this 1.6 into 5 and it will be 8 centimeter. So that way you have to draw the vector diagram. So here roughly I will tell you what is happening here with the help of the triangle law, and then we will draw the diagram over here. So here you can see the weight is acting in the downward direction. Weight is acting in the downward direction like this. Weight is acting in the downward direction. Here I can say this is nothing but the weight, and the aerodynamic lift, okay, which is acting at 30 degree, okay, to the left of the vertical, 30 degree to the left of the vertical. So this itself is a vertical line, that is the line of the weight, but it is in the downward direction, but the air lift is acting upwards in the vertical direction and with the 30 degree angle to the left. So here it is going from this point to this point, and it should be like 30 degree angle to the vertical. Okay. So this vector, this vector is showing you the aerodynamic lift, and this vector is showing you the weight. Here you can see this is a triangle law, because this is the tail of the weight and this is the head of the weight weight vector, and this second aerodynamic lift vector is going from this point to this point. So I can say this is the tail of the second vector, and this is the head of the second vector. Okay, so we are connecting here tail and head, and that's why it is the triangle law. And then this is nothing but the resultant, which is the centripetal force, which is going from the tail of the first vector to the head of the second vector. Okay, so this is the rough thing, and I hope you understood how this is nothing but the triangle law of the vector addition. Okay, so here I just told you, if you connect the head and tail of the two vectors with proper magnitude and direction, the third side itself is the addition of these two vectors, that is nothing but the resultant. So here I will draw the proper diagram. Suppose this is nothing but the weight of the, this is nothing but the, this is the weight vector, and suppose this is a 5 centimeter. We have to draw with proper scale, because this numbers are given and the line is showing me the magnitude. So here I should write down this is nothing but the weight, which is nothing but the weight vector. Okay, now this is the tail. This is the tail. You shouldn't write down this in the pair diagram. This is the tail and this is nothing but the head. I am just showing here just for your understanding purpose. Now the second vector, which is going from this this point towards the 30 degree towards the left. Okay, so it should be automatically how much? If it is the first one is a 5 centimeter, this should be automatically the 8 centimeter, and you have to draw this with the proper scale. And here I can write down this is nothing but the This is nothing but the aerodynamic lift force. So this is nothing but we can write down over here aerodynamic lift force. Okay. So two vectors are drawn here. You have to show the proper arrows. This is the head of the first vector, this is the tail of the first vector, this arrow is the head of the second vector, and this is the tail of the second vector. So we are connecting here the tail and head. Okay, so connecting the tail of the first vector and the head of the second vector is nothing but, you can say, this is nothing but the resultant force, and this resultant force is nothing but the centripetal force. Okay, so here can draw. It should match. Basically, it should properly match. So you should draw it very properly. When you draw with the scale, it will be matching. Here and here, finally, I can write down this is nothing but the resultant force, or you can say the centripetal force. Okay. So addition of these forces is what? It is nothing but the resultant force, and it is directed towards the left, which is nothing but this point. You can say this point is nothing but the center of that imaginary circle. Okay. So here the resultant force or centripetal force is directed towards the left, is the center of the imaginary circle. So what we have drawn here in our diagram is correct. This is towards the left because addition of these two vectors is giving you the resultant vector to the left. There is nothing but the third side. This you can say the first side of the triangle, weight, second side of the triangle, aerodynamic lift, third side of the triangle is nothing but centripetal force. So here we will simply apply the triangle of vector addition. Now the C part of the question, the speed is constant as the airliner flies in the circular path. State and explain why, what is happening to the velocity. So we have learned about the speed and velocity before. Speed is just the magnitude of the motion, and the velocity is nothing but magnitude along with the direction. So see in this circular motion, you can see if it is moving with the constant speed, then we can say the speed is constant. Or if it covers the equal distances with equal interval of time, then we can say it is a constant speed. But what about the velocity? Suppose here the object is over here at this point, and suppose object is here at this point. At these 2 points, the object is moving continuously. So see the velocity is always the tangential. Velocity should be in this direction here. The velocity is always tangential. And if I consider this point, at this point also velocity is always directed towards the along the tangent. So what is happening at every point? The tangent is telling you the direction of velocity. Okay, this tangent is telling you the direction of velocity. If I consider the constant speed, okay, here it is also shown the direction of the velocity. But if you consider if the particle is moving with such that it is covering the equal arcs, okay, that means equal distances in equal interval of time, we can say the speed is constant. Speed is constant. But though the speed is constant, the direction of velocity is always changing because it is always tangential, and that's why velocity is not constant, because velocity is speed along with direction. Though the speed is constant, but since the direction is changing, we must say the velocity is also changing. So here, so we can write down, since the direction of the motion of airliner is changing, velocity, and say the velocity is changing, but the speed remains constant. So speed is nothing but the scalar quantity, but velocity is a vector quantity. So though the speed of the airliner is constant, since its direction of motion is changing continuously, we can say the velocity is changing. Okay. So I hope you understood this concept between the speed and velocity. It is changing because it is nothing but the vector quantity and it requires the direction as well. So here we are ending our structured problems.